Calculate the integral from -1 to 4 of the absolute value of x minus 2 plus 3 dx using areas. Okay, if I'm using areas, I'm going to have to sketch this thing. The absolute value of x would look like that. And then the -2 would shift it forwards 2. And then the +3 would shift it up 3. And so it would be here, like that. Okay, so I need to start at -1 and I need to go up to 4. And that's the area I'm looking for here. All right, well, that's 2 trapeziums. And I know how to calculate the area of trapeziums. I just need these heights. When I put -1 into this formula, I've got -1, -2, which is -3. The absolute value of -3 is +3, plus another 3 is 6. So that'll be a height of 6 there. We already figured out that this was 2, 3. And putting 4 in, 4 minus 2 is 2. This will be 5. Okay. So why don't I label those? This can be trapezium A and this can be trapezium B. Area A, a trapezium. Now, trapezium have to average the 2 parallel lengths. Half times 3 plus 6, that's those heights there, and times by the distance between them. That was a 2, wasn't it? So that distance is 3. So I've got a half times 9 times 3 times 27. All right, 27 over 2. Area B, which is also a trapezium. So I have to average these two, that's 3 and 5, times the distance between them, which is 2. Now half times 2 is 1, and so that's just going to give me 8, which for the purposes of adding would be 16 over 2. And so the total area, which is the integral from -1 to 4 of absolute value of x minus 2 plus 3 dx, would be 27 over 2 plus 16 over 2. 27 plus the 10 would be 37, plus a 6 would be 43 over 2. And that's the area. Just to check, just a second, this area here is a rectangle. It's 3 high and 5 wide, so that'd be 15. Now, this is 2, so that'd be half of a square. So 4 by 4 plus, that's 2 by 2, which is 4 divided by 2, which would be 2, so we're up to 17. And then this bit would be 3 by 3, which is 9 divided by 2, which is 4.5, which is 21.5. And yes, that is 43 over 2. Okay, cool. So the area really is 43 over 2, and that is the definite integral.